Hi friends, good evening. Welcome back to my channel Belagali's class. Yes friends, in the previous video class I have completed linear differential equations. Connected with linear differential equations I have done everything. The two forms dy by dx plus py equal to q, integrating factor solution. Another form is dx by dy plus px equal to q, where p and q are functions of y here. Then the method of finding integrating factor, then the general solution. Even I have done examples on particular solutions, some applications type examples, everything we have completed with previous video. The part left in differential equation is this, my friends, formation of a differential equation. Formation of a differential equation, it comes under 2-mark question. Normally, examples on this formation are alternative to find the order and degree of a differential equation. That also comes under 2-mark question. And normally, examples on formation will come under 2-mark. Here also there are some 3-4 examples are a little bit lengthy. If they ask, those examples may come under 3-mark questions. 3-mark questions. Yes, my friends. It is a formation of a differential equation. Yes. So far, 1 minute, see what we have done, my friends. It is a formation of a differential equation. What we have done? We have done this. What is that? We know the method of finding the solution of a differential equation. We know the method of finding the solution of a differential equation. Solution of a differential equation. For example, just one example I have taken. Find the solution, otherwise solve the equation, or find the general solution, anything. General solution of the differential equation, x into dy by dx equal to 2x square plus 1. This is the given differential equation, my friends. We want to find its solution. I told what is solution of a differential equation. Solution of a differential equation is a relation between the dependent and independent variables, that is, relation between x and y, which is free from derivatives and will substitute or satisfy the given differential equation. Such a relation between x and y is known as solution of the differential equation. Then, solution of a differential equation is free from dy by dx. Yes, my friends. To make it free, we are integrating the things here. Before integrating, we are separating the variables. Variables are separated. This. I have to separate the variables. Dy is only one term here. X upon dx, you have to bring this side. RHS is 2x square plus 1. Above x becomes down dx comes to numerator dx. Simplify this. 2x square upon x is 2x plus 1 by x into dx. Now dy equal to, it is a function of x with respect to x. Variables are separated. Once the variables are separated, you have to integrate both sides. Yes, my friend. You have to integrate LHS with respect to y, RHS with respect to x. Integral of 1 is y, with respect to y is y equal to 2 into. Integral of x with respect to x is x square by 2 plus 1 by x means it is log x plus constant of integration. My friends, this 2 cancels with 2, giving y equal to x square plus log x plus c. This 2 is the solution of the differential equation 1. 2, see my friends, what is your observation? It is a relation between x and y, which is free from arbitrary constants, which is free from dy by dx. It is free from dy by dx. Such a relation means equation, containing or equation in terms of x and y is the solution of the differential equation. This is the solution of the differential equation 1. So 2 free from dy by dx, this is what? Containing dy by dx. 2 is the solution of the differential equation 1. Yes, my friends, we have done from differential equation to solution, from dy by dx to free from dy by dx. Yes, my friends. What you wanted here? Formation of a differential equation. We want to find a differential equation. What is a differential equation? It is an equation that contains derivatives. Yes, my friends. Then what they give? They give the solution. Now it is a reverse process, ulta. They give the solution of a differential equation. With the help of the solution, the method of finding the differential equation. The method of finding the differential equation. That method is nothing but formation of a differential equation. That method is nothing but formation of a differential equation. Here, my friends, conversely, one is the differential equation. One is the differential equation whose solution is given by equation 2. One is the differential equation whose solution is given by equation 2. So, from differential equation to solution, from ulta, solution to differential equation. How to find a differential equation when the solution is given? That method is known as formation of a differential equation. That is, I have written one line here, my friends. Therefore, formation of a differential equation means find a differential equation whose solution is given. Find a differential equation whose solution is given. Without the solution, we can't find the differential equation. Is it correct, friends? When the differential equation is given, the method of finding what? Solution. It is known as finding the general solution or finding the particular solution, like this. Now, when the solution is given, the method of finding its differential equation, that method is known as formation of a differential equation. Yes, my friends. Next we have to study for another method. Another method, you mean finding a differential equation when its solution is given. Yes, my friends. Procedure to find or form a differential equation when its solution is given. Procedure to form or find a differential equation when its solution is given. First step, or we can say rule 1. What is given, my friend? The solution is given. That solution is what? It is an equation. That solution is an equation which contains x and y and arbitrary constant. This arbitrary constant is same as order of the differential equation. Then only it is called as what? General solution. Therefore, solution of a differential equation normally they give which is free from dy by dx in terms of x and y, and it contains number of arbitrary constant equal to order of the derivative. Yes, my friends, what is from this? What is clear? See. If it contains one arbitrary constant, what is the order of the differential equation? 1. If it contains two arbitrary constant, what is the order of the differential equation? If there are two arbitrary constants, my friend, C1 and C2, in this case, differential equation must contain a derivative of what? Second derivative. Derivative of order 2. One constant, order is 1. Two constants, order is 2. d2i by dx. Yes, my friends. Say, what is the step 1? Differentiate the given equation, which is the solution of a differential equation with respect to x, as many times as the number of arbitrary constants, it contains means differential equation contains. Yes, my friends, phi del. If only one arbitrary constant, we wanted only dy by dx term. To get dy by dx term, you have to differentiate once. Yes or no? Therefore, what is this first rule? Differentiate the given solution of a differential equation with respect to x as many times as the number of arbitrary constants. You mean, if that solution contains one arbitrary constant, differentiate the given equation once with respect to x. If it contains two arbitrary constants, differentiate the given equation twice with respect to x. I tell my friends, if it contains two, it must contain a derivative of order 2, high. Number of arbitrary constants equal to order of the differential equation. 2 means its order is 2. To get d2y by dx2, we have to differentiate this relation how many times? 2 times. First time is dy by dx, second time is d2y by dx. Therefore, if the solution contains two arbitrary constants, differentiate the given equation twice with respect to x. Like that, my friends. If it contains 3, then you have to differentiate 3 times. Normally you have only order 2, my friends, order 2. Therefore, if it contains one arbitrary constant, differentiate once. 2 arbitrary constants, differentiate twice with respect to x. What is this, my friends? First step. What you are going to do? You have to differentiate the given equation with respect to x. Then after differentiating the equation, you get what? It is an equation which contains derivatives. It is a equation which contains derivative. That you can name it as what? It is a differentiated equation. After the differentiation, you get what? An equation which is called as differentiated equation. Then you get, my friends, two equations. One, the given equation. What is other? Differentiated equation. As the given equation contains what? Number of arbitrary constants. Then see here. To get a differential equation, is it contains arbitrary constant? Nothing. As it doesn't contain arbitrary constant, last step, in the step 2, you must eliminate the arbitrary constants from the given equation, which is the solution. And after the differentiation, after the first step, you get an equation which is called as differentiated equation. Then you have to eliminate the arbitrary constants from the given equation as well as differentiated equation. By making use of these two equations, you must eliminate the arbitrary constants. If necessary, simplify it. After the simplifying, the equation so obtained, which is free from arbitrary constants. Such an equation is known as required differential equation. I hope, my friends, it is clear. Just the highlights, main points I will tell once again. Main points. See, in this case, we want to form a differential equation. But what we have done so far, when the differential equation is given, we know the method of finding its solution. This one example I have given. This is the equation, variable separable type, dy one side, this x comes down, this dx goes up. Simplifying this, you get this. Variables are separated. After separating the variables, you have to integrate. Integrating, you must add constant of integration. Yes, my friend. What is this? This 2 is the solution of 1. Started with an equation which contains dy over dx. With this method, we have eliminated what, my friends? Dy over dx. It is an equation which is free from dy by dx and which contains number of arbitrary constant equal to order of the differential equation, then only such a solution is known as general solution. Yes, my friend. 2 is the solution of 1. This is a method from 1 to 2. This formation means we wanted what? A differential equation. What is a differential equation? It is an equation which contains the derivative. Then it is free to get an equation which contains derivative. My friends, we have to go with this method. So formation means we have to differentiate what? The given solution of differential equation as many times the number of arbitrary constant the solution contains. If the solution contains one arbitrary constant, differentiate once. If it contains two arbitrary constants means what? What is the order of the derivative? 2. To get d2i by dx2, you have to differentiate this y. This is for the first time, this is for the second time. The same thing, my friends, I have written here. In the first step, differentiate the given equation, which is the solution of the differential equation with respect to x, as many times as the number of arbitrary constants it contains. If it contains once, differentiate once. If it contains two, differentiate twice. The same thing I have written. If it contains one arbitrary constant, differentiate the given equation once. If it contains two arbitrary constants, differentiate twice with respect to x. Like that, my friends. Then, first is the solution, which is the given equation. Then, after differentiating that given equation, we get second, which is named as differentiated equation. Then you have two equations. One is a given equation. Another is a differentiated equation. Among these two, you eliminate that arbitrary constants. That elimination of arbitrary constants from these two equations gives the required differential equation. This is the method, my friends. Don't have any doubts why you are differentiating. Why? Free is a solution. Differential equation is an equation which contains derivatives. To get the derivatives from this, we have to differentiate. How many times? 1, once. 2, twice. Simplify if necessary. The equation so obtained is the required differential equation. This is the method, my friends, to form a differential equation. Examples are quite simple. No confusion. You must be thorough with differentiation now. Why? From the solution to differential equation. Method is differentiation. From the differential equation to solution. To eliminate derivatives, we have to go for what? Integration method. Therefore, in this case, we are integrating. Integrating gives the solution. Differentiation gives the differential equation. Yes, my friends. I have taken one sample example here. These examples important under 2-mark questions. Eliminate the arbitrary constant from the equation y equal to cx plus 5 and form a differential equation. Yes, given equation is what? Y equal to cx plus 5. It contains what? One arbitrary constant c. This 1 contains equation 1 contains one arbitrary constant c. Then differentiate equation 1 once with respect to x. Differentiate derivative of y with respect to x is dy by dx. Cx is c. Y. Derivative of x is 1. You know, in general, derivative of kx is k, cx is c. 5 being a constant, its derivative is 0. Therefore, you have c equal to dy by dx. My friends, this is a differentiated equation. This is the differentiated equation now. And what is the given equation? This is your given equation. Now it remains to eliminate c. Eliminate c between eliminate C arbitrary constant from given and differentiated equation. This is differentiated. Eliminate C means you have to put the value of C. Yes, put this value of C in equation 1. This is given. Yes, it becomes what? Y equal to x into C is what? dy by dx plus 5. Now, this is the equation which contains derivative and it is free from arbitrary constant. So, the equation so formed, the equation so obtained is the required differential equation. This is the required differential equation. This is the required differential equation. This is the method, my friends. Main steps. Solution of the differential equation is given. First, trace the number of arbitrary constant. If it contains 1, differentiate once. Right. This is differentiated. Eliminate this C from these two equations. Put the value of C. Elimination of C is the method that whatever you get will be the required differential equation. My friends, this is the method. I give 2 minutes. Copy it. Copy it. Yes, friends. Now I do some examples on this formation of a differential equation. One sample I have done. One sample I have done. Yes. Now I do the examples from exercise 9.3. Examples from exercise 9.3, my friends. This is the heading. Form a differential equation. Differential equation representing the given family. Family means it is given in the form of equation. Given family of curves. By eliminating the arbitrary constant. Arbitrary constant following. Yes, my friends, it is a solved example in the textbook. It is a solved example in the textbook. Y equal to mx. Y equal to mx. My friends, can you tell? And it is appeared in the question paper board exam under 2-mark question. 2-mark question. Y equal to mx. Can you tell what is this? It doesn't contain C. then what it represents? It represents a family of lines passing through the origin. If it is m equal to 1, it is a, yes my friend, this is one line. It is m equal to 1, yes, means it is y equal to x. This is another line, y equal to 2x. This is third line, y equal to 3x. Like this, my friends, you get what? Family of curves. This is known as family of curves. In this case, curves means what? It is a straight line. Therefore, for different values of m, you get different lines. That set of lines is nothing but, instead of naming this as a set, we are naming this as what? Family of straight lines. Yes, my friends. What is the given equation? Given equation is y equal to mx. You name this as when it is given. Next, you have to differentiate. It contains what? One arbitrary constant. No need to write it. I have written for the first here. One contains one arbitrary constant. Differentiate once. Again, it contains what? One arbitrary constant. Differentiate once. Differentiate one with respect to x. This is dy by dx equal to m into derivative of x is 1. From this you get the value of m is dy by dx. My friend, this is your second equation. Eliminate m arbitrary constant between equations 1 and 2. What is your mathematical approach? Put m equal to dy by dx in equation 1. That's all. You have to put what? M equal to dy by dx in equation 1. This is y equal to x into dy by dx. This gives, my friend, it is x into dy by dx minus y equal to 0. Or you may write dy by dx equal to y upon x, any form. Even you can write only this much. What is this? This is the required differential equation. I hope you know the method. This is the method, my friends, to find the differential equation. Just 2 mark examples, simple examples. Yes, friends. Second one. This is y equal to a into sin x plus b. Same title. Form a differential equation representing the given family of curves by this equation. Okay. Yes, my friend. What is given equation? Equation is y equal to a into sin x plus b. Name this as 2. No. Equation 1. Yes. It contains how many arbitrary constant? This is 1. This is 2. Yes. Equation 1 contains. Two arbitrary constants. So differentiate one differentiate 1 twice with respect to x. Twice with respect to x. Yes, differentiate once. dy by dx equal to a into derivative of sine is cos x plus b, and derivative of x is 1, inner derivative of angle, but it is 1. For the second time, differentiate with respect to x. Differentiate again with respect to x, second time. d2i by dx, this is a, what is derivative of cos? Minus sine x plus b. Once again, derivative of x is 1. Tell my friends, what is this value? This is a sine x plus b is y. Substitute. This is minus y. Automatically, the arbitrary constants are eliminated. You get minus y, which is free. Bringing this side, d2i by dx to that minus y becomes plus y equal to 0, which is the required differential equation. Oh, understood. Usually, exponential and trigonometry comes, y comes, repetition. If you differentiate the same equation twice, you get minus sine. It is nothing but your y minus y, taking this side is plus y equal to 0. It is a differential equation. See, it contains two arbitrary constants. What is the order of the derivative? These two. So that must be matching, they must be equal. Then only this is the general solution of the given differential equation. If this is the general solution, then it must be a differential equation. This is the method of finding differential equation when its solution is given. This is the method, my friends. Like this, we have to do some number of examples. That's all. It is also solved example in the textbook. Yes, my friends. Next example is xya plus y by b equal to 1. It is an example number 1 where in exercise 9.3, you have to find the differential equation. Yes. What is the given equation? Given equation is, I write the same 1 by a into x to make it convenient for the differentiation. Instead of x by a, it is 1 by a into x plus it is 1 by b into y equal to 1. You name this as 1. Same thing, 1 contains how many arbitrary constants? 1 contains 2 arbitrary constants. So, differentiate 1 twice with respect to x. Yes, ma'am. First time differentiating 1. It gives, my friend, 1 by a into derivative of x is 1 plus 1 by b into what is derivative of y with respect to x is dy by dx equal to 0. Simplify it, it is what? 1 by b into dy by dx is minus 1 by a, shifting that side. Then what is dy by dx is, it is minus b by a. In such cases, my friends, what is your RHS? Purely constant. If you differentiate second time, you have to differentiate twice. If you differentiate second time, Elimination of what? Arbitrary constants. Differentiate again with respect to x. Second time. This gives derivative of first derivative is second derivative equal to, my friend, purely constant derivative is 0. What is this? Require differential equation. Require differential equation. Hope it is clear. It is clear. Next, my friends. Yes. My friends, it is that earlier question that sign is appeared 3 times in the question paper. 3 times in the question paper. Even this example is appeared once in the board exam. All these appeared under 2 mark questions. 2 mark questions. Even it is also appeared, my friends. Appeared. Next example. Next example is y equal to next example is y equal to a cos omega x plus b sin omega x. This is the given equation. They mention here, my friends, why the students will under confusion. This is 1. This is second, this is 3, no. But in this case they mention where A and B are arbitrary constants. A and B are arbitrary constants. But omega is a fixed constant. It is not arbitrary, it is a fixed constant. It is a fixed constant. Yes, my friend. Then only arbitrary are 2. You have to differentiate 2 times this. Yes, given equation. Given equation is y equal to a cos omega x plus b sin omega x. Friend, it is 1. Again, 1 contains 2 arbitrary constants, not fixed. Arbitrary are 2. The friend is mentioned here clearly. 1 contains 2 arbitrary constants. 2 arbitrary constants. So, differentiate 1 twice with respect to x. Twice with respect to x. Yes, my friend, once. First time, differentiate 1 first with respect to x. What is this, my friend? This is your 1. Differentiate with respect to x. Derivative of y dy by dx equal to a into derivative of cos minus sin omega x into omega, my friend. Don't forget. Why? Angle is other than x. When the angle is other than x, you have to differentiate the angle. Kx is k, omega x is omega. Plus b. Sin is cos into omega. That omega is common, my friends, I take out. This is minus a sin omega x plus b cos omega x. This is once, but you have to differentiate how many times, my friends? Twice. Second time, differentiate this again with respect to x. That again till second time, again with respect to x. Yes, derivative of first derivative. is second derivative. Omega being a constant, fixed constant, remains as it is. Derivative of this, it is minus a. Derivative of sine is cos. Omega x into omega, derivative of omega x. Again plus b, but derivative of cos is minus sine. Minus sine omega x into derivative of omega x is omega. Once again, my friends, omega is common. Taking omega common, even this minus is also common, my friends. Minus omega is common. This is minus omega is common. Minus omega is common. Minus omega. You are left here. A cos omega x plus b sin omega x. Friend, simplify. This is minus omega square. Tell what is this? A cos omega x. A cos omega x plus b sin omega x is by 1 nothing but y. This is y because by 1. Taking this side, therefore d2y by dx2 minus becomes plus omega square y equal to 0, which is the required differential equation. Differential equation. It is also a good example under 2-mark question, my friends. Simple. If the examiner is simple, definitely they will go for what? Repeated differentiation. That's all. Differentiation. Next example. I hope it doesn't need repetition. It is a quite simple example of differentiation. Even this example you have done under what? Successive derivative. If you see your video, you can find it in successive differentiation. Yes, friends. Next example. Next example is y equal to e to the power x into it is a cos x plus b sin x. B sin x, where a and b are arbitrary constants. Where a and b are arbitrary constants. It is an example from the textbook. From the textbook. It is the 5th example in the exercise 9.3. 5th example in exercise 9.3. Yes, my friends. Again, what is the given equation? Given equation is y equal to e to the power x into a cos x plus b sin x. You have to name this as what? Equation 1. Same history, same thing, same steps. Again what? Equation 1 contains two arbitrary constants. Two arbitrary constants, a and b. So, differentiate equation 1 twice with respect to x. Twice with respect to x. Yes. Differentiate first time gives y derivative. Tell my friends, what is the difference? It is only one term. But in this case, it is a product now. This is one term, e to the power of x is another term, It is a product now. You are differentiating this product by using product formula. Yes, friend. It is e to the power x as it is. Derivative of cos minus sine plus b sine is cos x. Plus, my friend, you have to keep this bracket as it is. A cos x plus b sin x into derivative of e to the power x is e to the power x. This is e to the power x, my friends. But it becomes lengthy. Then you can simplify this. Yes, my friends. The method I want to little change here. I bring this e to the power x down. This is y upon e to the power x is this. Bring down. Then you lift this to the numerator. If you take this to the numerator, it becomes what? That is y into e to the power x plus x becomes minus x, lifting equal to it is a cos x plus b sin x. This is 1, my friends. Now this is 1. Differentiate what? Differentiate 1 first time, then second time, because two arbitrary constants are there. Differentiate 1. In this case, my friends, you have to apply the product formula here, which is simpler than what I had proceeded first. This is simpler. What is this? E to the power minus x into derivative of y is dy by dx plus y into derivative of e to the power minus x into minus 1 by other than x, derivative of power, equal to this is a minus sin x plus b, derivative of sin is cos x. This is first time differentiation. But what is your observation, my friends? E to the power x is common. X is common here. You are left with e to the power minus x is common. Dy by dx minus y equal to RHS. It is a sin x plus b cos x. I hope my friends clear. I will explain once again. See, given equation, what is the change I have done? I brought this to the down. This is RHS. Lift this to the numerator. Otherwise, you can write this as one. First, e to the power minus x into y equal to this. Instead of writing y into e to the power minus x, you write e to the power minus x into y. E to the power minus x into y equal to this. Differentiate with respect to x. Product formula. First function, derivative of second function plus second function, derivative of first, e to the power minus x. E to the power minus x into derivative of power is minus 1 equal to a cos is minus sine plus b sine is cos. E to the power minus x is common, left. Dy by dx minus y equal to this. Same. Two arbitrary constants to differentiate once again. Differentiate again with respect to x. Yes, friends, this gives. Again, it is a product formula. This is e to the power minus x into derivative of this. Derivative of first derivative minus derivative of y dy by dx plus this bracket as it is. What is that bracket? Dy by dx minus y into derivative of e to the power minus x. It is minus x into power minus 1 equal to minus a sine is cos x, b cos is minus sine x. Yes, friends, simplify it. Yes, friends, simplify it. See, e to the power minus x, e to the power minus x is common. E to the power minus x is common. Yes, you are left inside. First bracket is this, d2i by dx2 minus dy by dx. d2i by dx2 minus dy by dx. Here, this plus with minus is minus here. Plus with minus is minus. This is taken common, minus dy by dx. Yes, my friend, what about this? This is minus y. Minus y with minus 1 is plus y. Plus y. This bracket is complete. Equal to. Minus is common. What is this? A cos x plus b sin x. Oh, understood. Here. Minus common. A cos x plus b sin x. But what is this by 1, my friends? By 1, it is nothing but e to the power minus x into y. E to the power minus x into y equal to minus e to the power minus x into y because by 1. Divide both sides. By e to the power minus x. This cancels, gives d2i by dx2 minus 2 times dy by dx. This is plus y equal to, this is cancelled, minus y. Bring this side. This is same, my friends. Plus y minus y becomes plus y equal to 0. That is d2y by dx2 minus 2 into dy by dx plus 2y equal to 0. This is required differential equation. Differential equation. My friends, I give 1 minute. Please verify it. Is it correct? Verify it. Yes, my friends. I will explain once again. This is the given. We want to form a differential equation whose solution is this. This is solution is given. Given equation, bring down LHS, RHS. Lift to the numerator, e to the power plus x becomes minus x. Name this as equation 1. Differentiate 1 first time because it contains two arbitrary constants. First differentiation. Product formula is here. Yes. As it is, derivative of second as it is, derivative of e to the power minus x, e to the power minus x into derivative of power is minus 1 equal to derivative of RHS a minus sine plus b, derivative of sine is cos. Yes, my friend, e to the power minus x, e to the power minus x is common. This is RHS. 2 times, second time, differentiate this again with respect to x. Product formula, yes. First function as it is, derivative of this bracket, derivative of first derivative, second derivative, minus derivative of y with respect to x, dy by dx, plus this bracket as it is, derivative of e to the power minus x is e to the power minus x into minus 1, RHS, derivative, minus a, sine is cos, plus b, derivative of cos is minus sine. Simplified, e to the power minus x, e to the power minus x is out. This is left, d2i by dx to minus dy by dx. This plus with this minus 1 is minus here. This is minus derivative, minus with this minus is plus y equal to, in RHS again minus is common. Taking minus common, a cos x plus b sin x, a cos x plus b sin x, my friends. 10. This is nothing but e to the power minus x into r, because by 1, yes, divide both sides by e to the power minus x. You mean e to the power minus x cancels from both sides, leaving this bracket, same time, twice, plus y. This minus y taking this side, it becomes again plus y. Y plus y is 2y. Required differential equation. Yes, friends. Next example. Right.
Sir.
Yes. Okay, my friends, I do one simple example. Form a differential equation whose solution is y equal to C1 e to the power mx plus C2 e to the power minus mx. Right. This is given differential equation. Given equation is y equal to C1 e to the power mx plus C2 e to the power minus mx. What is your observation, my friends? Power of e, they are same but opposite in sign. This is plus, this is minus. Opposite in sign. Again, it contains what, my friends? How many arbitrary constants? This is 1, this is 2. Name this as 1. 1 contains 2 arbitrary constants. Therefore, differentiate 1 twice with respect to x. First time, differentiate 1 first time with respect to x. Gives derivative of y dy by dx. C1 into e to the power mx. What is the derivative of power m? Plus C2 minus mx. What is the derivative of power? minus m. What is common now? M is common. It is C1 e to the power mx minus C2 e to the power minus mx. Differentiate again with respect to x. Again with respect to x. Derivative of first derivative. Second derivative. M being a constant as it is. Same. C1 mx derivative of power minus C2 minus mx derivative of power is minus m. Again this m is common. M is common. This is C1 e to the power mx minus with this minus is plus C2 e to the power minus mx. M into m square. What is the value of this by 1 is y, because by 1. Taking this side, therefore d2i by dx2. Taking this side, minus m square y equal to 0. This is required differential equation. Required differential equation. Simple example, my friends. Simple. I do a few more examples on this formation in the next video, next class. All these examples are quite simple, normally under 2-mark question. Some lengthy examples may appear under 3-mark questions, my friends. Prepare. These are alternative to order and degree of a differential equation, these examples. Yes, my friends, today this much is enough. Thank you, friends. Bye. Namaste, Namaskara, Namashinyo. Good day, my friends. Good.